When you think of American infrastructure, what comes to mind? Perhaps the iconic orange-red cables of the Golden Gate Bridge or the endless streams of cars rushing down the interstate highways. These are, without question, America's pride. After all, the Golden Gate Bridge was completed in 1937, and the Hoover Dam had already stunned the world even earlier, back in the 1930s. For nearly a century, the Golden Gate Bridge has stood as a symbol of American engineering brilliance, a monument to an era of courage and miracles when people truly believed that nothing was impossible. It didn't just connect two shores, it connected dreams. The Golden Gate in San Francisco was one of the toughest engineering challenges ever taken on. Against incredible odds, it stood strong for over 80 years, not just a landmark, but a living piece of American history. But that golden age of American engineering now feels like a distant memory. While the U.S. continues to debate how to fund repairs for its aging bridges, on the other side of the Pacific, China is redefining the very limits of human engineering. Deep in the mountains of Guizhou, a new giant has risen, the Huajiang Canyon Bridge. Before even opening to traffic, it faced one of the most extreme load tests in the world. 96 heavy trucks, weighing a total of 3,700 tons, were driven onto the bridge, while over 400 sensors monitored every stress point, deformation, and vibration in real time. And the result? It passed flawlessly. In doing so, it didn't just prove its safety, it rewrote the global standards for bridge monitoring and structural resilience. This isn't just a bridge, it's a statement, a declaration that the center of the world's engineering miracles is shifting to the east. So, what makes this bridge a true symbol of 21st century infrastructure? China is leading a once-in-a-century infrastructure revolution, building record-breaking mega projects at an astonishing pace. The nation's high-speed rail network now extends over 26,000 kilometers, connecting Beijing, Shanghai, Shenzhen, and Chengdu. It has become a global symbol of modernization and efficiency while laying the foundation for long-term economic growth. In 2023, China's investment in infrastructure reached $2.44 trillion, a 6% increase from the previous year, demonstrating its strategy of using infrastructure as the core engine for economic expansion and global integration. These massive investments not only expand global supply chains, but also create opportunities for technological collaboration and innovation, strengthening China's position on the world stage. One of the most striking examples is the Huajiang Canyon Bridge in Guizhou Province, an area once divided by rugged mountains. Scheduled to open in September 2025, the bridge stretches 9,480 feet in total length, with a main span of 4,660 feet, reducing the travel time across the canyon from 70 minutes to just 90 seconds. The Huajiang Canyon Bridge is not only a transportation link, but also integrates features like a glass walkway, bungee jumping, paragliding, and cliffside trails, making it a new tourist landmark comparable to the Golden Gate Bridge in San Francisco. Completed in just 3 years, this project showcases China's breathtaking construction speed, its ability to overcome extreme geographic challenges, and its growing strength as a global leader in modern infrastructure. The Huajiang Canyon Bridge is not only another milestone in the history of Chinese bridge engineering, but also a pinnacle achievement in the field of suspension bridges worldwide. On the map of Guizhou Province, you can hardly find any large flatlands. About 92.5% of the province is covered by mountains and hills, containing 1.258 million individual peaks, cut apart by 8 major rivers and countless tributaries that carve the land into bottomless gorges. Building an expressway across such terrain almost means confronting the very folds of the earth head-on. The Huajiang Canyon, located between Liupanshui and Changshinan in Guizhou, serves as a crucial section of the Lian Expressway. To open this route, engineers face 2 choices: either avoid the canyon by detouring over the mountaintops, resulting in a smoother alignment but at an enormous cost, or lower the bridge height by adding more tunnels and steep slopes, making construction far more complex and dangerous. In the end, they chose the most extreme solution: to leap directly across the Huajiang Canyon in a single span at an altitude of 625 meters. At such an extraordinary height and span, ordinary bridge types, such as steel girder bridges, arch bridges, or cable-stayed bridges, were no longer feasible. There was only one answer left: a super long-span suspension bridge. The Huajiang Canyon Bridge has a total length of 2.89 kilometers, a main span of 1,420 meters, main towers rising 262 meters tall, and a bridge deck standing 625 meters above the canyon floor. It officially surpasses the Baypanjiang Bridge, becoming the highest bridge deck in the world. Upon completion, it will cut the travel time across the canyon from 70 minutes to just 90 seconds. But how do you build a bridge that holds the world's highest deck in one of the longest spans? In theory, it sounds simple. 3 steps. First, build 2 strong towers, then install 2 secure main cables and anchor them firmly. And finally, hang the bridge deck using vertical suspenders. Just like that, a suspension bridge is born. Of course, in reality, it's not that simple. To make the 262-meter-tall bridge towers stand firmly atop the mountains, engineers first had to find rock-solid ground, then drive 24 massive concrete piles deep into the bedrock. How deep? The deepest reaches 68 meters, about the height of a 20-story building. Above ground, each tower, more than 200 meters tall, was divided into over 40 segments. Using a hydraulic climbing formwork system, engineers poured and lifted each segment continuously, allowing the tower to grow upward at an astonishing rate of 0.8 meters per day. At the same time, they poured an enormous concrete anchor block, roughly half the size of Beijing's National Stadium. Why so huge? Because only with its 400,000-ton self-weight could it securely hold the 2 main cables, which would later bear the entire weight of the bridge deck. This is known as a gravity anchor. On the opposite side of the canyon, however, there wasn't enough space for such a massive structure. So engineers used the mountain itself as the anchor, embedding the cable deep inside a specially excavated tunnel, creating what's called a tunnel anchor. With both towers and anchors complete, it was time to install the main cables. From afar, these cables might look thin, but in reality, each is nearly 1 meter thick, wide enough for a person to walk on. But then came another challenge. How could these enormous cables cross a canyon more than 1,400 meters wide? The answer: drones. A drone first carried a thin pilot rope across the canyon, connecting both sides. That rope was then used to pull a thicker rope, and that one pulled an even thicker one, repeating the process several times until a temporary aerial walkway, known as a catwalk, was built between the 2 towers. Along this catwalk, engineers began installing the cable strands. Each strand composed of 91 high-strength steel wires, each just 5.7 millimeters in diameter. The first strand was the most critical. It served as the reference line for all subsequent strands. Using total stations on the ground and Beidou satellite positioning, engineers kept the installation error within 2 millimeters, ensuring that every following cable would be perfectly aligned and tensioned to precision. And when all 217 cable strands have been pulled into position, they are compressed and fastened together using a cable compactor, finally forming a single main cable. Once both main cables were fully tensioned, the project moved to the next critical stage, lifting the main girder. The main girder of the Huajiang Canyon Bridge weighs the equivalent of 95 Y-20 transport aircraft and was divided into 93 segments, which were assembled simultaneously from the center toward both sides. Each segment weighs 200 tons, roughly the same as lifting an entire blade set of the world's largest wind turbine. What made it even more difficult was that all this lifting had to be done under the constant threat of strong canyon winds. Thanks to a smart cable crane system capable of millimeter-level precision control, the main girder was finally joined seamlessly, marking the completion of the world's highest bridge's main structure. Construction of the Huajiang Canyon Bridge began on January 18, 2022. By April 2023, the first bridge tower had risen to 653 feet. In January 2024, the main suspension cables were fully installed. By January 2025, the main girder was joined, and in August 2025, the bridge underwent a full-scale load test. Finally, in September 2025, it is scheduled to officially open to traffic. In just over 3 years, engineers completed this record-breaking megastructure in terrain once deemed almost impossible for modern construction. During the load test, 96 heavy trucks, with a combined weight of 3,700 tons, were placed across the bridge, while more than 400 sensors continuously monitored stress, deformation, and vibration in real time. The results confirmed that the bridge meets the highest international safety standards, and through a digital twin system, a long-term health monitoring model was established to track the bridge's condition in real time. The Huajiang Canyon Bridge is not just a bridge. It is a smart megastructure integrating intelligent sensing, digital twin technology, and wind control systems. Equipped with over 400 high-precision sensors, it continuously measures temperature, wind speed, stress, and vibration, with all data transmitted to a central digital twin platform. This enables engineers to predict potential fatigue points, optimize maintenance cycles, extend the bridge's lifespan, and reduce maintenance costs. In terms of wind and vibration control, the bridge adopts a new aerodynamic deck profile and high-performance steel box girders to minimize the risk of vortex shedding and resonance. Additionally, LiDAR sensors continuously monitor wind speed and direction, while temperature-controlled smart chips and cooling water systems embedded within the bridge towers help prevent structural stress concentration under extreme weather conditions. The significance of the Huajiang Canyon Bridge goes far beyond its technological marvel. It shortens the cross-canyon travel time from 70 minutes to just 90 seconds, allowing once-isolated mountain towns to finally join China's national expressway network for the first time. The bridge sits along the Lian Expressway, a 94-mile corridor connecting western Guizhou with the Pearl River Delta, one of China's most economically dynamic regions. Its opening will not only boost logistics efficiency, reduce fuel consumption and vehicle wear, saving millions of dollars in economic losses every year, but also stimulate tourism, hospitality, and eco-industries across a 19-square-mile area. The bridge deck itself incorporates a glass skywalk, bungee platforms, earning it the title of China's new landmark on par with the Golden Gate Bridge. The service area is named Yundu, meaning crossing the clouds via one bridge. There, visitors will stand 1,000 meters above sea level, gazing across the sea of clouds, and witness firsthand the awe-inspiring power of this engineering masterpiece. The Huajiang Canyon Bridge is not only a pride of Guizhou province, but also a symbol of China's leap in bridge engineering technology. On the global highest bridges ranking, China occupies 8 of the top 10 spots, with half of them located in Guizhou alone. The completion of the Huajiang Canyon Bridge has once again inscribed the world's highest bridge under China's name. Compared with the Milo Viaduct in France, the Huajiang Canyon Bridge wins on deck height. Compared with Japan's Akashi Kaikyo Bridge, it faces more complex, mountainous terrain and wind conditions. Compared with the Golden Gate Bridge in the US, it surpasses it in span, wind resistance, and structural precision. It not only transcends the old definitions of world's highest and world's longest, but also establishes a new paradigm for suspension bridge design under extreme terrain conditions, providing a technical precedent for future projects spanning the Himalayas, the Andes, and other deep canyon regions. Across Guizhou province, there are now over 30,000 bridges spanning valleys and rivers. These bridges not only weave together the high-speed transportation network, but also connect the lifeblood of the economy, cultural ties, and hopes for daily life. Guizhou was once called a place where no patch of land is level, but today, with the opening of the Huajiang Grand Canyon Bridge, this misconception is being completely rewritten. Through the connection of bridges, mountains are no longer barriers, and even the clouds can be traversed. Millions of peaks now finally have millions of paths forward. The Huajiang Grand Canyon Bridge not only links the roads on both sides of the canyon, it also connects Guizhou to its future. In the future history of bridge engineering, people will remember this name, Huajiang Grand Canyon Bridge, a miracle descending from the clouds. With a deck height of 625 meters, it sets a new world record. Built in just 3 years, it demonstrates the power of China's infrastructure. And with digital intelligent management, it opens a new era in bridge engineering. It is more than just a bridge. It is a signal that China is leading the next era of human infrastructure. As the sun sets over Guizhou's mountains, its towers gleam like beacons of a nation's progress, a symbol of China's relentless pursuit of innovation, and a reminder that no peak is too high, no valley too deep, when human determination meets engineering genius. The world's highest bridge, the Huajiang Grand Canyon Bridge, stands as proof that the future of infrastructure has already arrived. Next, let's take a look at China's megadams. Imagine this: massive dams generating record-breaking power, tunnels cutting through impossible terrain, and bridges so high it feels like walking in the sky. These projects aren't just massive, they're built at unbelievable speed. highways, sea-crossing bridges, and high-speed rails, rising in record time. But the real question is, how did China do it? What secrets lie behind these engineering miracles? The answer lies within the breathtaking mega-projects that have reshaped our world. Let's begin with one of the most iconic of them all, the Three Gorges Dam, the largest hydropower project on Earth. Stretching 2.3 kilometers long and standing 181 meters tall, it consumed 28 million cubic meters of concrete and 460,000 tons of steel. It's not only the world's most powerful hydroelectric station, generating up to 118.8 billion kilowatt-hours per year, but also a masterpiece of inland navigation, allowing 10,000-ton cargo ships to travel from Shanghai all the way to Chongqing. Its 5-step ship lock and the world's largest ship lift have transformed the Yangtze River into a true golden waterway. But that's not all. Hidden within the heart of the dam lies one of China's most astonishing engineering marvels, the world's largest ship elevator. Standing 120 meters tall, this colossal steel structure works like an elevator for ships, capable of lifting vessels weighing up to 3,000 tons in just 40 minutes. A journey that used to take hours. It uses a counterweight balance system with over 100 cables and giant hydraulic mechanisms to ensure absolute precision and stability. For many engineers, this isn't just a transportation system, it's a symbol of how China dares to redefine what's possible. From the flow of the Yangtze to the rise of this monumental structure, the Three Gorges Dam represents more than power. It represents control, vision, and mastery over nature itself. But the true power of the Three Gorges Dam goes far beyond electricity and navigation. It stands as the ultimate flood defense for the entire Yangtze River basin. During the monsoon season, it can precisely regulate massive flood surges, storing over 22.1 billion cubic meters of water in its reservoir, reducing the downstream flood peak and protecting hundreds of millions of people in major cities like Wuhan, Nanjing, and Shanghai. Over the past decade, it has successfully intercepted and released floodwaters multiple times, buying precious time for downstream regions to prepare and respond. This isn't just an engineering victory, it's a triumph of human intelligence over the forces of nature. If the Three Gorges Dam represents China's power to command nature, then in the heart of its capital, another miracle of speed was unfolding. Imagine the busiest traffic artery in a megacity, jammed day and night. Now imagine that the core bridge of that network suddenly became unsafe and had to be replaced. But there's a catch. The traffic can't stop. No months-long closure, no chaos. For most countries, that would be a logistical nightmare. But for Chinese engineers, it was a stage to perform a miracle. This was the Sanyuan Bridge Replacement Project in Beijing. Carrying over 200,000 vehicles every day, the bridge had suffered severe fatigue and deformation over time. A conventional replacement would paralyze the city for months, so the engineers came up with a radical idea. Don't rebuild, just replace. At midnight on November 13, 2015, Beijing shut down the overpass. Then what followed was an engineering symphony of cranes, cutters, and precision machines. The old bridge was sliced into 27 giant segments, the heaviest weighing 139 tons, nearly the weight of 2 blue whales. Each piece had to be lifted with absolute precision. One wrong move, and the entire structure could collapse. It was like playing a high-stakes game of Jenga, suspended in midair. Meanwhile, the new bridge, already pre-assembled nearby, weighed a staggering 1,300 tons. How could they move such a massive structure and place it exactly on the old piers? The answer: China's self-developed Shentuo modular transporter. Each transporter had 96 wheels, capable of carrying extreme loads. Dozens of them moved in perfect synchronization, lifting, rolling, and positioning the new bridge with millimeter accuracy. Using GPS guidance and laser alignment, engineers ensured the final deviation was less than 1 millimeter. The result? The entire replacement was completed in just 43 hours, less than 2 days. A potential months-long traffic nightmare, solved through speed, innovation, and fearless precision. This wasn't just construction, it was a declaration. In China, impossible is only a matter of time. But this is still not the limit of China's speed. American netizen, after seeing this, was completely shocked. He simply couldn't believe that China was able to build and put a bridge into use in just 43 hours. Because in the United States, building a simple bridge takes years. For example, a street light in front of my house burned out, and it took an electrician 5 months just to fix it. Seeing these complaints from overseas netizens, I can't help but laugh and cry at the same time. Even British academics were in awe of China's infrastructure speed. In one of his academic lectures, he remarked,
China has actually soared. It's meteoric. Former Czech President Václav Havel, I think, put it best. He said, all this has happened so fast, we haven't yet had time to be astonished. To remind myself how astonished I should be, I occasionally look out the window in my office in Cambridge at this bridge, which goes across the Charles River between the Kennedy School and Harvard Business School. In 2012, the state of Massachusetts said they were going to renovate this bridge. It would take 2 years. In 2014, they said it wasn't finished. In 2015, they said it would take 1 more year. In 2015, they said it's not finished. We're not going to tell you when it's going to be finished. Finally, last year, it was finished 3 times over budget.
The professor then talked about his trip to Beijing, where he drove past the famous Senyuan Bridge.
Now, compare this to a similar bridge that I drove across last month in Beijing. It's called the Shenyang Bridge. In 2015, the Chinese decided they wanted to renovate that bridge. It actually has twice as many lanes of traffic. How long did it take for them to complete the project? What do you bet? Take a guess. Take a look. The answer is 43 hours. Now, of course, that couldn't happen in New York.
After these words, cheers erupted throughout the room. The audience's faces were filled with disbelief, staring at the professor in awe, as if saying, "This can't be real. This can't be real." The professor added that this was not just a triumph of technology, but also an organizational revolution. China has taken parallel engineering to the extreme design, prefabrication, and demolition, all happening simultaneously, compressing time to its physical limits. He also pointed out why China has become so powerful today.
Behind this speed and execution is a purpose-driven leader and a government that works. The most ambitious and most competent leader on the international stage today is China's President Xi Jinping. And he's made no secret about what he wants. As he said when he became president 6 years ago, his goal is to make China great again.
That's right. This wise British professor made a very valid point. The Chinese always approach things with incredible efficiency, never dragging their feet. While other countries are still debating bridge construction plans, Chinese engineers have already torn down the old bridge and built a new one. This is the essence of China's speed. When all the braggarts around the world witness China's speed, every other pace seems as slow as a snail. China continues to create astonishing stories for the world. China's speed is the speed of global development. Wherever the Chinese go, construction and progress follow. This is what true global leadership looks like. Time and time again, the speed of China's infrastructure projects has shattered the world's understanding of what is possible. But this is still not the limit of China's speed. If replacing an entire bridge in just 43 hours sounds insane, then what you're about to see next will completely defy belief. Chinese engineers once built a fully functional, high-speed railway station in just 9 hours. It sounds impossible, yet it happened. The project took place in Longyan, Fujian, as part of a major railway upgrade. The goal was ambitious, to cut a 7-hour journey down to just 1.5 hours. So what was the secret? Modular prefabrication. Months before construction began, engineers mapped out every step like a chess game. They pre-assembled the track sections, sleepers, ballast, and even station platforms. Each component designed to fit together like giant Lego blocks. On the day of construction, 1,500 workers divided into multiple coordinated teams, removing old tracks, replacing switches, hoisting prefabricated segments, backfilling gravel, reconnecting power lines and signal systems, all moving in perfect synchronization. Laser-guided instruments ensured every track segment was aligned to millimeter precision. By dawn, the final weld was complete. The new station was live and ready for trains to run, all in just 9 hours. From midnight to morning, from old to new. This wasn't just speed. It was discipline, coordination, and engineering mastery on a national scale. A systemic miracle that only China's infrastructure machine could pull off. China's engineering marvel even made headlines in the UK, where a popular TV show sparked heated debates about the project, while using it to roast their own country's notoriously inefficient railway system.
In the country, we're hearing these complaints about our transport structure.
On substandard train services, just wondering, for the sake of argument, how the Chinese do these things. They were able to build a whole new station in the space of 9 hours by flooding it, thousands of workers. We should be much more imaginative about getting infrastructure in instead of condemning people to being isolated in remote areas.
Was it 9 hours they built?
9 hours.
Sounds
Look
like
it
a
up.
television reality
There is
show.
a video here. You've got to watch
get the workers
this
out
thing.
to take the
While British media were still amazed by China's speed, across the Atlantic, Americans were just as stunned. On a popular U.S. talk show, the host said,
"The problem, and they fix it. They build a dam. We debate what to rename it. That's why their airports look like this, and ours look like this. In San Francisco, it took 10 years just to get 2 bus lines through environmental review. The Big Dig, a tunnel in Boston, took 16 years. China once put up a 57-story skyscraper in 19 days. They demolished and rebuilt the Sanyuan Bridge in Beijing in 43 hours. We binge watch, they binge build. When COVID hit Wuhan, the city built a quarantine center with 4,000 rooms in 10 days, and they barely had to use it because they quickly arrested the spread of the disease. They were back to throwing raves in swimming pools, while we were stuck at home surfing the dark web for black market Charmin. We're not losing to China. We lost.
and that line captures the difference perfectly. Because in the U.S., a single bridge replacement or subway extension can take a decade or more. Meanwhile, China builds entire high-speed networks in the same time frame. When renowned British motoring expert Jeremy Clarkson first visited China, he was absolutely blown away by the country's infrastructure. Driving along China's highway bridges, he remarked,
In 1988, China had no motorways at all. And now, 30 years later, it has 84,000 miles of them. That's more than any other country in the world. And they're only just getting into their stride. Since 2011, they've been building 6,000 miles of motorway every year. 6,000 miles a year! It beggars belief, and it's not like the terrain is easy.
Here, though, there ain't no mountain high enough, and there ain't no valley low enough to stop them. This bridge, for example, is 34 miles long. And then there's this one, the Baypanjiang Bridge. You could fit the London Shard underneath it, twice over.
I'm telling you, in Britain, we're doomed.
when it comes to bridge building technology, Britain simply can't compare to China. In the world of bridge engineering, there's a famous saying, for bridge construction, look to Europe and America before the 1970s, to Japan in the 1990s, and to China in the 21st century. Today, China's bridge construction has reached the world's top tier. Chinese bridges have become not only a shining postcard of China, but also an important symbol of its comprehensive national strength. Over half of the world's long-span bridges are built by Chinese engineers. In the rugged mountains of southwest China, a colossal steel dragon soars into the sky, linking the provinces of Guizhou and Yunnan. This is the Baypanjiang Bridge, once hailed as the world's highest bridge of title. The vertical distance from the bridge deck to the valley floor of the Baypanjiang Bridge reaches 565 meters, equivalent to 200 stories high. Building such a long-span bridge is no easy feat. The Baypanjiang Grand Canyon boasts treacherous, terrain-complex geological conditions and is subject to relentless winds, dense fog, and low temperatures. No one had ever thought it possible to construct a bridge in such an extreme environment. Yet Chinese engineers were not intimidated by these challenges. With ingenuity and courage, they overcame obstacle after obstacle. To build bridge piers on such steep cliffs, engineers invented the moving formwork system, assembling the piers section by section like building blocks. They also utilized smart concrete, a material that automatically adjusts its temperature to prevent cracking, ensuring the piers are both robust and durable. The 2 concrete main towers of this bridge stand majestically, with the tallest reaching 883 feet, equivalent to the height of a 90-story building. The bridge deck is constructed from 22,000 tons of steel, with a total weight equal to that of 5 Titanic ships. The vertical distance from the valley floor to the bridge deck even surpasses the height of the New York World Trade Center, enough to fit an entire skyscraper. The total length of the bridge's steel cables reaches 250 miles, which, if stretched out, could extend from New York City all the way to Washington, D.C. The entire bridge spans the canyon, measuring about 1 mile in length, while the highest point of the tower peaks at 2,461 feet. The height from the valley floor to the tower's tip is greater than the combined height of 2 Eiffel Towers plus the Statue of Liberty. Such a scale of engineering and technical difficulty represents the pinnacle of human bridge-building history. This level of engineering and technical difficulty is not only a masterpiece in the history of bridge construction, but has also earned widespread international recognition. Even President Trump himself said publicly, "China's achievements in bridge construction are astonishing. They have accomplished projects we could never imagine, with incredible speed and quality. The United States needs to learn from China's determination." At the same time, U.S. President Trump also expressed his deep affection for China, emphasizing how much he loves the country.
I love China. People say, oh, you don't like China. No, I love them. But their leaders are much smarter than our leaders. And we can't sustain ourselves with that. There's too much. It's like take the New England Patriots and Tom Brady and have them play your high school football team. That's the difference between China's leaders and our leaders. China, you go there now, roads, bridges, schools, you never saw anything like it. They have bridges that make the George Washington Bridge look like small potatoes. And they're all over the place.
The Baypanjiang Bridge began construction in October 2010 and officially opened to traffic in December 2016. Upon its completion, it immediately caused a global sensation. Major media outlets rushed to cover the story.
Well, a walk across a new bridge in China could send your heart racing because it's the world's highest, and it opened today. It stands more than 1,800 feet above the valley below, and that's more than a third of a mile. The bridge cuts the drive time between two southwest Chinese cities from 4 hours to just 1.
John Davis, president of the American Society of Civil Engineers, admitted, "If this bridge were built in the United States, it would take at least 20 years. Yet Chinese engineers completed this epic super project in just 6 years. Such speed is extremely rare in the history of bridge construction." They even installed AI-powered monitoring systems on both sides of the canyon, constantly adjusting the tension of every single steel cable in real time. Think about that. An entire mountain-spanning bridge, fine-tuned by artificial intelligence. The sheer capability to execute such a massive engineering project. It's hard to believe China is still called a developing country. In fact, it's more advanced, more precise, and more ambitious than anything achieved by most developed nations. As the New York Times commented, China is redefining modern governance with Tesla-style innovation in the infrastructure sector. With each mega project built, China continues to overcome world-class engineering challenges through innovative techniques and advanced construction methods, earning it the moniker infrastructure maniac. Moreover, China has undertaken major projects in numerous other countries, each emblematic of its development drive. Behind China's global leadership in infrastructure lies not only a leap in technology, but also the support of a mighty nation. For over a century from the devastation at the founding of the People's Republic of China, it has been the successive struggles of generations of Chinese engineers that have painted the picture of today's prosperous China. And yet, this is not the end for China. In the future, China will continue to help more developing countries modernize, create new opportunities for development, and build a better, more livable world for all. Each bridge, every road, and every project connects cities and countrysides, the present and the future, China and the world. Chinese infrastructure has not only reshaped the face of China, but also exemplified the strength, spirit, and speed of the nation. The infrastructure maniac will never stop. From record-breaking bridges and high-speed railways to colossal dams and entire cities rising from the sea, these projects aren't just about size. They're about speed, precision, and vision. In less than a decade, China has built over 45,000 kilometers of high-speed rail, more than the rest of the world combined. It has launched the world's largest hydropower dam, rerouted rivers across thousands of kilometers, and turned remote islands into symbols of modern engineering. Once a nation catching up, China is now leading the world, pushing the boundaries of science and transforming imagination into steel and concrete reality. So today we'll uncover the genius, the technology, and the unstoppable drive behind the country that the world now calls the infrastructure maniac. Across the past 2 decades, China has carried out a series of mega projects that literally reshaped the land itself. They have redefined transportation, energy, and even what it means to be a developing country. From the Qinghai-Tibet Railway that runs across frozen highlands to the Hong Kong-Zhuhai-Macau Bridge crossing the South China Sea, from the world's largest solar farms in the desert to sky-high bridges spanning mountain gorges. Each of these marvels stands as a testament to China's relentless drive to build the impossible. This is national confidence, a belief that nothing is truly impossible. It's what turned China from a follower into a leader. And there is no better place to witness this audacious spirit than in the waterways that traverse China's rugged mountains and deep valleys. The challenge of navigating these rivers is among the most difficult in the world, but Chinese engineers have redefined impossible. Take the Three Gorges Dam as an example. A 3,000-ton ship can be lifted a staggering 113 meters in just 40 minutes. And this incredible feat isn't achieved through brute force. It relies on ship lifts that harness the principles of gravity and water buoyancy. Even more remarkable is the Gupatan ship lift on the Huajiang River. At 199 meters high, it breaks world records by lifting vessels in 3 stages with astonishing speed and precision. These engineering marvels combine the ancient wisdom of Archimedes' principle with cutting-edge hydraulic systems and counterweight technology. They transform once impassable river sections into efficient navigation channels, saving hours of travel while showcasing extraordinary modern design. You might wonder, how can a single system lift thousands of tons so precisely? Why are ship lifts safer, faster, and more energy efficient than traditional locks? Keep watching, and you'll be amazed at how every component operates in perfect harmony. Rivers are nature's highways, connecting towns, cities, and even crossing borders. But not all rivers are easy to navigate. Some have steep drops, rocks, or even waterfalls. How can ships safely pass these natural obstacles? The answer lies in dams, locks, and ship lifts, engineering marvels that allow massive vessels to traverse waterways once considered impossible. Let's start with dams. Essentially massive walls that hold back water, dams create reservoirs with multiple functions, supplying drinking water, generating hydroelectric power, and controlling floods. But they also create a height difference between upstream and downstream waters, which requires ships to climb to pass. This is where locks come in, essentially water elevators for ships. Imagine a huge water chamber with gates at both ends. A ship enters, the downstream gate closes, and water flows in from upstream, raising the vessel to the higher level. To descend, water is released and the ship slowly lowers. The principle is simple, yet ingenious. For centuries, locks have allowed countless vessels to climb rivers and canals, greatly facilitating navigation. For example, on the Mississippi River, a network of locks and dams allows fully loaded barges carrying grain and coal to penetrate deep inland. But what if the height difference is too great for traditional locks? The answer: the ship lift. This is an advanced innovation, taking the concept of a water elevator to the extreme. Imagine an elevator in a skyscraper, but instead of people, it carries an entire massive ship. The concept isn't new. Early versions existed in the 19th century, but today's modern ship lifts are engineering masterpieces. Take the Three Gorges ship lift again. It can raise a 3,000-ton ship 113 meters in just 40 minutes, equivalent to lifting a giant vessel to the height of a 30-story building. The process relies on steel cables, hydraulic systems, and precision machinery to ensure smooth and accurate operation. Why are ship lifts so important? They ensure uninterrupted cargo transport. Rivers and canals are among the most efficient ways to move heavy goods. Without locks and ship lifts, many everyday products would cost more and take longer to arrive. In regions with steep terrain and high dams, ship lifts are true game changers, saving time, energy, and costs while opening entirely new navigation possibilities. So how do they actually work? Think of a ship lift as a giant water tank. A ship sails into it, buoyed by the water, and the entire tank plus ship is lifted or lowered as one unit. The key is balance. This is Archimedes' principle in action. The water displaced equals the weight of the ship. This makes the combined weight of the ship and water controllable and stable. At the Three Gorges ship lift, a 120-meter steel trough holds both ship and water. Steel cables on either side connect to massive counterweights. As the trough rises, the counterweights descend. As it lowers, the counterweights rise. Like a giant seesaw, this balance drastically reduces energy consumption. Powerful motors and precision gears ensure smooth movement and speed control. Even thousands of tons can be lifted safely within 40 minutes. The supporting towers for these cables and motors rise over 170 meters, taller than most skyscrapers. Engineers even accounted for solar expansion, which could tilt the tower slightly, designing the system to auto-correct and keep the trough perfectly level. Another iconic ship lift is the Gupatan ship lift on the Huajiang River. Taller than the Three Gorges lift at 199 meters, it uses a three-stage lifting process. This allows one ship to enter the second stage while another is being lifted in the first, greatly increasing efficiency. Its hydraulic system is incredibly powerful, raising a 500-ton vessel at 8 meters per minute, completing the entire process in just 10 minutes. Safety is paramount. At Three Gorges, if a cable or motor fails, the braking system immediately locks the trough. Even in a power outage, the vessel remains securely suspended. The system is designed to withstand storms, heavy rain, and other extreme weather, continuing operation without interruption. Every year, the Three Gorges and Gupatan ship lifts undergo thorough inspections and maintenance, with motors, cables, and counterweights replaced before wear becomes an issue. The Three Gorges ship lift operates 22 hours a day, only stopping for scheduled maintenance. Smaller lifts also exist, such as the Shuiku ship lift on the Minjiang River, with a 500-ton capacity. Despite its smaller size, it is compact, ingeniously designed, and blends seamlessly with the surrounding terrain. This demonstrates the adaptability of shiplift technology, which can be tailored to fit various river environments. In the end, a shiplift is far more than a mechanical device. It represents the fusion of ancient wisdom and modern technology, combining Archimedes' buoyancy principle with hydraulic power and precision motors. They make navigation faster, safer, and more environmentally friendly, showcasing how human engineering can overcome the most formidable challenges. From the towering mountain valleys to the roaring rapids, Chinese engineers have used ship lifts to allow massive vessels to navigate waterways that were once impassable. Their ingenuity enables ships weighing thousands of tons to climb in just a matter of minutes, turning rivers into highly efficient transport routes. On an even grander scale, Chinese engineers have set their sights on the energy sector. The Baypanjiang Hydropower Station, located on the upper reaches of the Yangtze River, is one of the largest and most technically complex hydropower projects in the world. It is not just a marvel of electricity generation, it is a bold challenge to the limits of nature and engineering. The dam rises 289 meters high, roughly the height of a 100-story skyscraper. Its installed capacity reaches 16 million kilowatts, making it the second largest hydropower station in the world, just after the Three Gorges Dam. What makes it truly remarkable is its location, deep in a seismic and geologically unstable canyon. Building here was like constructing a skyscraper on a shifting mountain. Yet Chinese engineers defied the odds, using innovation and precision to turn the impossible into reality. They developed the world's first 1 million kilowatt hydroturbine generator and applied a double curvature arch dam design combined with AI-driven smart construction systems, achieving concrete placement accuracy within mere centimeters. Baypanjiang not only broke multiple world records in hydropower engineering, but also marked China's rise as a global leader in clean energy and dam construction. It's proof that China's pursuit is not just about speed, but about sustainable power, the kind of power that can reshape the world's energy future. As one international report put it, the Baypanjiang Hydropower Station is a perfect harmony between human ingenuity and the forces of nature. That's the true spirit of Chinese engineering. If the Baypanjiang Hydropower Station represents China's power, then the next project showcases China's wisdom, the ability to make water itself flow against nature's design. This is the South to North Water Diversion Project. China's geography has always posed a unique challenge. The South has water, the North does not. Only 20% of China's population lives in the South, yet it holds nearly 80% of the nation's water resources. Meanwhile, the North, home to megacities like Beijing and Tianjin, has long suffered from chronic drought. To solve this 1,000-year problem, China didn't wait for nature to change. It decided to redefine it. Launched in 2002 and now fully operational, the South to North Water Diversion Project spans over 2,700 kilometers, crossing 10 provinces and municipalities, and consists of 3 main routes: the Eastern, Central, and Western routes. It is the largest and most complex water diversion system ever built in human history. The Central route, starting from the Danjiangkou Reservoir, crosses the mighty Yellow River and delivers the waters of the Yangtze River all the way to Beijing and Tianjin. Along the way, it passes through more than 3,000 bridges and culverts and over 200 tunnels, Some underground channels stretch for more than 100 kilometers, but this is more than a canal. It's a lifeline. Today, every drop of water that flows into a Beijing tap may have begun its journey thousands of kilometers away in the upper reaches of the Han River. This project has transformed arid northern cities into green oases, improving the lives of hundreds of millions of people and laying the ecological foundation for China's sustainable future. It is not just an engineering feat, it's a bold act of vision, proving once again that when faced with imbalance, China doesn't wait for change, it creates it. From the high-speed trains racing across the plains to the ship lifts that allow massive vessels to conquer treacherous rivers, from the powerful surges of the Baypanjiang Hydropower station to the south to north water diversion, quenching the lands of a nation. All of these projects converge into a single grand tapestry, a testament to the ingenuity, courage, and perseverance of Chinese engineers, and a reflection of a nation bold enough to turn the impossible into reality. These mega projects don't just transform transportation networks, energy systems, and cityscapes. They reshape the world's perception of what a developing nation can achieve. Like shining coordinates, they mark China's journey from a follower to a global leader. Every high-speed rail line, every dam, every tunnel, every bridge is not merely a collection of steel and concrete, but a crystallization of intelligence, bravery, innovation, and relentless dedication. And the future? China will continue to drive more mega projects, bringing technology, ambition, and hope to every corner of the world. It proves one thing: when humanity dares to dream and push boundaries, nothing is truly impossible. So tell us, how amazed are you by these Chinese engineering marvels? Share your thoughts in the comments, and don't forget to subscribe to our channel. Together, let's continue exploring the most astonishing feats of engineering on Earth. Thank you for watching, and we'll see you in the next video.